In December 2016, a single rain event dropped 176 millimeters of water in 24 hours on the hills of Viti Levu, turning the solid ground beneath the King's Road into liquid grease. This was a catastrophic failure where the earth itself liquefied, severing the primary economic artery of Viti Levu and costing the nation over $500 Fijian per trip in lost logistics. While tourists cruised the paved Queen's Road in the south, the north was paralyzed by a geological time bomb known as Smectite clay. But right now, a massive $124 million operation involving the World Bank and the Asian Development Bank is fighting back. We are talking about 54 kilometers of heavy pavement construction, cutting through mountains and bridging floodplains to finally close the ring around Fiji's main island. Engineers are drilling 20-meter steel tendons into the bedrock and building walls that flex like fabric to stop the mountains from collapsing. But with rainfall intensity increasing every year, can this 25-year design life really hold back the inevitable forces of nature? To understand why this project is so critical, we have to look at how Fiji was built. The King's Road didn't start as a highway, it started as a feeder track for bananas. When the original King's Wharf was constructed in Suva back in 1912, the road was just a muddy path designed to get copra and fruit from the eastern hills down to the ships. For decades, it stayed that way. While the southern coast got the glory with the Queen's Road upgrade in 1976, funded by the World Bank to support the tourism boom, the north was left behind. The King's Road became the forgotten sibling. By the early 2000s, the situation was a disaster. We call this the lost decade of upgrades. Contracts were signed and promises were made to seal the gap between Waito and Wailatua, but the projects failed. The road became a construction site that lasted for years. During the rainy season, buses would sink to their axles in mud, and farmers in Ra watched their crops rot because trucks couldn't navigate the slippery clay slopes. The old engineering methods just couldn't handle the ground conditions, and the people of Viti Levu waited over 11 years for a sealed road that actually worked. But the failures of the past revealed a terrifying secret about the ground itself, something that would force modern engineers to completely rethink how they built roads in the Pacific. The enemy here isn't just traffic, it is chemistry. The section of the King's Road running through the central corridor sits on top of Smectite clay. For those of us who aren't geologists, Smectite is a mineral that acts like a sponge. When it is dry, it is stiff and hard, almost like rock. You can drive a truck over it and it feels solid. But the moment it gets wet, the microscopic structure of the clay expands. This expansion pushes the soil particles apart. Friction drops to zero. The soil loses all its strength and turns into a heavy, sliding sludge. In engineering terms, the shear strength vanishes. This is what caused the massive Kasavu landslide. The ground didn't just break, it flowed. To defeat this, the new project, known as KRUPB, couldn't just pour gravel on top. They had to stabilize the mountain itself. The solution involved a technique called soil nailing. Imagine trying to staple a rug to a hardwood floor so it doesn't slip. Now imagine the rug is a sliding mountainside and the floor is the solid bedrock deep underground. Contractors drilled holes up to 20 meters deep. That is about the length of 2 school buses, horizontally into the hill. They inserted hollow steel bars and injected high-pressure grout, cement, through them. These nails bond the loose, wet surface soil to the stable rock core deep inside the mountain. It creates a reinforced block of earth that holds the road up even when the clay gets wet. But stopping the land from moving is only half the battle. You also have to handle the water that triggers the movement in the first place. Water management on the King's Road had to be aggressive. The engineers installed deep longitudinal V-drains running alongside the road. These aren't just ditches, They are designed to lower the water table, the level of water underground, so that it stays below the road foundation. If you keep the Smectite clay dry, it stays strong. For the steepest sections, where the road hangs off the side of a cliff, they couldn't use standard concrete walls. Concrete is rigid. If the ground shifts even an inch, concrete cracks and fails. Instead, they used geosynthetically confined soil, or GCS walls. Think of this like high-tech sandbags. They built walls up to 7 meters high using layers of compacted dirt wrapped in super strong fabric sheets. This design is brilliant because it is flexible. If the mountain moves slightly during an earthquake or a storm, the fabric wall moves with it. It stretches but doesn't break. It effectively floats on the shifting ground while still supporting the heavy weight of the highway. At the Kasavu slip, they combined this with micropile A-frames. These are small, high-strength piles driven into the ground at angles to create a rigid A-shaped skeleton underground, transferring the weight of the traffic past the slip plane and into the solid earth below. Now that the mountain was pinned in place, the team had to build a surface that could handle 25 years of punishment. The most visible change for anyone driving the new King's Road is the width. The Fiji Roads Authority adopted the Austroad standard, the same rules used in Australia and New Zealand. The new road is exactly 11 meters wide. This dimension is specific and calculated. You have 2 traffic lanes, each 3.5 meters wide. This allows a heavy sugarcane truck or a logging trailer to travel at 80 kilometers per hour without its wheels crossing the center line. On the old 6-meter roads, trucks had to slow down or drop a wheel onto the dirt to pass each other, which destroyed the road edge. But the real revolution is the remaining 4 meters. On each side of the road, there is a 2-meter sealed shoulder. In developed countries, this might just be a breakdown lane. But in Fiji, the road is the center of village life. It is a footpath. It is a marketplace. By sealing these 2-meter strips, the engineers created a dedicated zone for pedestrians. This separates the grandmother walking to church or the children walking to school from the logging trucks thundering past at highway speeds. It is a safety feature that directly targets the 3-star IRAP safety rating required by the World Bank. The pavement itself is built to last. They excavated the old rotten soil and replaced it with layers of crushed rock. For the surface, they used a specific chip seal design. While asphalt is smoother, chip seal, stones embedded in bitumen, is incredibly durable and provides high skid resistance in wet tropical weather. However, in high-stress areas, like steep hills or intersections where heavy trucks brake hard, they used asphalt concrete to prevent the road surface from rippling like a rug. Building this level of infrastructure in a straight line is hard enough, but trying to do it through the middle of living communities brought a whole new set of challenges. The King's Road isn't an empty highway. It is a linear village. Communities like Nyavu, Nakia, and Wailatua are strung out along the road edge. This meant the construction site was effectively inside people's front yards. One of the biggest logistical hurdles was the dig once policy. In the past, a new road would be built, and 6 months later, the phone company or the electric company would come along and dig a trench through the new pavement to lay cables, ruining the waterproof seal. For KRUP A and B, the contractor installed dormant conduits, empty pipes, under the road before laying the surface. This means that in 5 or 10 years, when Telecom Fiji or Energy Fiji Limited wants to upgrade their lines, they can just pull the cables through the existing pipes without breaking the road surface. The project also had to navigate the human economy. Surveys found that at certain points along the road, dozens of women rely on roadside stalls to sell corn, mangoes, and sasa brooms. You can't just bulldoze these stalls. The project had to integrate them. The wide shoulders allow these vendors to set up safely back from the traffic. During construction, the contractor, Higgins, had to coordinate with the village headman to ensure these businesses could keep operating, sometimes moving them to the other side of the road while the heavy machinery worked. And then there was the timing. Construction started in June 2021, right in the teeth of the COVID-19 pandemic. The supply chain for sealing chips, the specific hard rock needed for the road surface, dried up because quarries couldn't operate at full capacity. The contractor had to implement strict health protocols while trying to move thousands of cubic meters of earth in the rain. The financial scale of this undertaking is enormous for a small island nation. The western section, KRUP-A, cost approximately $37 million, while the more complex central section, KRUP-B, came in at over $54 million. This funding is part of the larger Transport Infrastructure Investment Sector Project, TIISP, a clever financial bucket that allows the government to shift money where it is needed most, like when funds were diverted to emergency repairs after tropical cyclones Yasa and Anna. Criticism has been loud regarding the speed of the work, with speeding drivers already causing accidents on the newly finished, smooth sections. However, with the project effectively complete as of late 2024, the focus now shifts to maintenance. If overloaded trucks are allowed to crush this new pavement, all that engineering will be dust in a decade. The King's Road upgrade proves that with the right engineering, even the most unstable geology can be tamed. If you enjoyed this deep dive into the mega engineering of the Pacific, smash that like button and subscribe to the Ultimate Mega Builds channel. Drop a comment below. Do you think the 25-year design life will hold up against the tropical rains? Make sure you turn on notifications so you never miss another massive project breakdown. Thanks for watching.